Here we have a friction problem. Two blocks with a mass m1, m2, shown in the figure are free to move. The coefficient of the static friction between the block is 0.22, but the surface beneath m2 is frictionless. What is the minimum force F required to hold m1 against m2? So we have to make sure that there is a certain force applied F which holds m1 and m2, and it moves to the right. First of all, we know that the two objects will move to the right with an acceleration since there is a force, right? We have to draw a free body diagram. In the first case, there is a friction only between M1 and M2 block. Beneath M2, there is no friction. So the first equation, if you look at, consider the whole two blocks as one system, then you can say that sum of the forces is equal to the m1 plus m2 times acceleration. This is our first equation. Okay. Now the second equation will be by drawing the free body diagram, where we have the normal force between these two boxes, m1 and m2. So F will push the m1. This is a normal force 1 on 2. Then we have second normal force, which is the reaction force that is coming from m2, action reaction force. Then we have static friction, which is always against the motion, so it will be upwards static, and then the balancing force against static friction will be the weight of the m1g. Okay, so now second equation is basically if you look at the only m1, then you can say that sum of the forces is equal to the m1a. Now let's look at this separately here to m1. Then sum of the forces here will be what? F, since whatever is right side is positive, F minus n2 is equal to the m1a. Okay. Then what is next? Then third equation will be what? Third equation will be, in our case, is static friction is equal to the mu normal force. Okay, since normal 1 and 2 are the same. Okay, so let's keep it like this. Then what is the force which against the static friction here will be the weight, which is m1g. Okay, in that case we can say that static friction is equal to the weight, so that means mu n is equal to the m1g. Okay, then from here we have to find the Roman normal force, where it will be m1g divided by the mu static. Okay, so far we got how many equations? We got this equation, then we got this equation, second one, then finally we got this equation where F is equal to the m1 plus m2 times acceleration. Now in this case, what we can do is that we have to somehow cancel the acceleration because we don't have acceleration, so we can substitute. So from here we can say that acceleration. So we can say here that F divided m1 plus m2 is equal to the acceleration, and then you can take that acceleration and plug it here. Okay, so then you can say that F minus the normal force, you can substitute immediately here, m1g divided by mu s, then it's equal to the m1 F divided m1 plus m2. So that's it. From here you just have to find what is the F.